Okay, now we're going to talk about financial stuff in a little bit more depth than we did before. Learn some new definitions and learn how to do a couple more problems. Now first we want to talk about something called the APY, the annual percentage yield. To do that, to really get an understanding of what it is and how it differs from the APR, the annual percentage rate, we're going to go through a couple of exercises. Now first we want to find the accumulated balance if we invest $500 for 1 year at 8% simple interest. Now simple interest, that's where we use the formula interest equals principal times rate times time. So we would have $500 at 8% for 1 year. The interest would be $40, which means the accumulated balance would be the 500 plus the 40, which is $540. Now we want to find the relative change in the investment. We started with 500, we ended with 540. So the absolute change in the investment, we earned $40, and the way we would represent that with a subtraction is to do the 540 minus 500. The only reason we needed to do that is because to find the relative change, we know the $40 was the difference. Which do we divide by? The reference value is the 500 because it came second in subtraction, and that means the relative change in the investment over 1 year was 8%. Now in the second one, we want to find the accumulated balance for $500 invested for 1 year at 8% interest compounded annually. Now as soon as we see the word compounded, we know we're supposed to use the TVM solver on our calculator. So I'm not going to fill all that out here. Surely you've done that enough that you can figure this out. We ended up with a future value of $540 again. If that is how much we have at the end, we want to find the relative change in the investment. Well, the relative change is going to be exactly the same as it was up here. If we started with 500 and we ended with 540, everything that we did here will repeat down here. So the relative change would be 8%. Yeah, so far that's not too exciting, and you're probably wondering why I'm making you bother. Let's do it 3 more times. Once for quarterly, once for monthly, and once for daily compounding, and see the difference. Again, I ask you to pause this and figure out the answers on your own, and then start this back up to compare what you got with what I have. So if we do these on the calculator and find the future value for quarterly should have turned out to be 541.22. The future value for monthly would have been 541.50. And daily would have been 541.64. Now we want to find the relative change. So first we have to find the absolute change for each one of these. The absolute change. So 41.22. Relative change. 41.22 divided by the 500 is 8.24%. Alright, the relative change for monthly compounding, if we do the absolute, we get 4150 divided by the 500, which gives us 8.3% as the relative change. Monthly, $41.64 is the absolute change, and when we divide, we get 8.33%. Now what we're looking at here is the APR, the annual percentage rate, is the 8%. It was 8% for the simple interest, it was 8% compounded annually, 8% compounded quarterly, monthly, and daily. The APR was the same, but what was different was the compounding periods. If we compounded annually, then the relative change was the same as the APR. But if we compounded at any amount more than once a year, the relative change increased. It wasn't just 8% anymore, because you would earn interest and then you would get interest on your interest. This relative change in your actual account balance from the beginning of the year to the end of the year, that is what your APY is. It's the actual change, percentage change in your account balance over the course of a year. So here we have it kind of summarized. The annual percentage rate, that's the amount of interest that they say they're going to pay yearly, but that's the amount before compounding. If compounding happens once a year, the APR is the same as the APY, APY being, again, the annual percentage yield. If it's compounded more than once a year, if interest is compounded more than once a year, then the APY, the annual percentage yield, is actually going to be more than what the APR suggests. Now, for us, if we want to find the APY, we actually don't have to go through the exercise that we did. That was just so we could see it happening and prove to ourselves what was happening. On our calculator, there is a command that will find the APY. Now, the command is an arrow with EFF. EFF stands for effective, because the APY is also known as the effective rate. So they just didn't make up 3 different letters for the APY. Your calculator's going by its other name, the effective rate. So if I want to find the APR, or I want to find the APY for 8% compounded quarterly, I get my command with the EFF, and I type in 8%, and my CY for quarterly would be 4 times a year. And that should give me 8.24%, or something close to it, just like I found when I did it, by finding the relative change. Monthly, I would type in 8,12, and daily I would type in 8,365. And we should end up, when you round, with the same amounts we got previously. Now this is the way that we'll actually do it when you're asked to do it for problems. An endowment is, picture you've got this big pot of money and the only thing you touch is the interest that you earn off of it. That's what an endowment is. It's a permanent source of income because you never touch the principal. And that means what you are using is only the interest. This happens a lot of times with scholarships. An endowed scholarship means that it'll be around forever. Now, everything about this is going to be the same except for the future value. You recognize this type of problem because it says you want to have $50,000 per year forever. You don't want $50,000 period. You want $50,000 interest off of whatever your big pot of money is going to be. Okay, so let's just back up for a minute. Let's start from what we do know. We would like to retire in 25 years. And we want to have a retirement fund. Okay, let's talk about that in a minute. We want to make monthly payments, as it says, monthly payments. So that goes, remember, 3 places. We got an APR of 9%. Since we want to make payments, we're not going to start with any lump sum. We're going to solve for how much our payments need to be. And it's the future value that we've got to think about. The future value, we don't want $50,000. We want our interest to be $50,000 every year. So, if we're getting 9% interest, 9% of whatever we put in for our future value needs to equal $50,000. So for us to figure out what future value we need to have, we would divide by the 0.09. This is what my future value would need to be. Now again, I don't have to figure out how much that is, because if I type that in, just like the calculator will compute my n for me, the calculator will compute my future value for me. So my future value is going to be how much I want to draw every year divided by my interest rate. And because this is not looking for your interest to be a percentage, I do have to change it to a decimal. Solve for my payment, and according to this, if I can get 9% interest, if I deposit $495.54 every month for 25 years, I can have my $50,000 a year income for as long as I live. Total and annual return are talking about the return that you get on your investment. The total return is the relative change in the investment. Just relative change. Doesn't matter how long the investment was, just from the beginning to the end, what was the percentage of increase or decrease. The annual return is what your APY would be. That is, what interest compounded annually would you have had to found in a savings account to get the same return on your investment that you got in the problem. So there's 2 different parts to this. If you want to do the total return is the relative change. So all I care about is I started with 3,000, I ended with 8,400. That means for my absolute change, I made money. So I do the 8,400 minus the 3,000 gives me 5,400. To find the relative change, I need to divide that by 3,000. That's my reference value, and change it to a percent. Now you want to be careful here because this turns out to be 1.8. Then to change that to a percent, I need to move the decimal point 2 places. Just because it turned out to be a whole number doesn't mean that it's already in percent notation. My total return would be 180%. Now when I do the annual return is what I do on my TVM solver. And the fact that it's an annual return means my PY and CY will be 1. We don't want to talk about making any payments. $3,000 was my original investment. An investment is negative, and it was $3,000. My future value, I got back $8,400. Here's the only place where I care about the fact that it's been 4 years. 4 times 1 will stay 4, and I solve for the interest rate. When I solve for this interest rate, it turns out to be 29.4. So my annual return is 29.4%. What that means is if I put $3,000 in the bank, I would have had to find a bank that would pay me 29.4% annual interest to end up with $8,400 in 4 years. Now this is the same example except backwards, meaning we lost money. If we lose money, when we do the total return, when we do the absolute change, we have to arrange our subtraction so that we lose money. Oops, minus 8,400 gives me negative 5,400. And that also means when I find the relative change that I'm dividing by the 8,400. The 8,400 is now my reference value. And this needs to come out to be negative. And it's negative 64.3%, which means I lost over half of my initial investment. The annual return is going to look the same as it did before. Annual return for 4 years. I'm solving for my interest, not making any payments. This time I paid $8,400 and I got back $3,000. So if my total return was negative, I expect my annual return is also going to turn out negative. And it does, negative 22.7%. What that means is I lost 22.7% of my investment every year. They should both be positive or they should both be negative. And if you get an error, if you get an error that it won't compute anything, it's because you didn't do your signs correctly on your present value and your future value.